Okay, so for this example, we have a bullet fired into a block and emerges the other side. So we have a 13-gram bullet traveling 230 meters per second, and it penetrates a 2-kilogram block going 170 meters per second. If the block were at rest on a frictionless surface, how fast would it be traveling after the bullet emerges? So here we have the mass of the bullet, which is 13 grams, 0.013 kilograms. It was going 230 meters per second initially. The block is a 2-kilogram block, and it was at rest. After the collision, the bullet comes out on the other side, V1 prime, V1 prime is going to be 170 meters per second. We want to know the velocity of the block after the collision. So notice I have V1 prime and V2 prime as two separate things here because they're going to be moving independently of each other after the collision. There is a collision, so we know momentum is conserved as always. We have two separate objects before the collision, so the momentum of each is given by this. After the collision, we also have two separate objects, so the momentum of each of the separate objects is given this way. I want to know V2 prime, so I'm going to subtract M1 V1 prime from both sides. So I have the original momentum minus M1 V1 prime equals M2 V2 prime. And then I'll divide the whole thing by M2. Same thing here. And then I'm all set. So I have 0.013 kilograms times 230 meters per second plus 0 minus 0.013 kilograms times 170 and divide by 2.0. So, punch that in the calculator. We have basically what we have going on here is 0.013 times the difference in those two velocities, which is 60, and divide that by 2. I get 0.39 meters per second. So the block isn't moving very fast. If we looked at a situation where the bullet hit and stuck in the block, we would actually see a higher velocity than we do in this case, because if the bullet stuck in the block, it would be sharing more of its momentum with the block, but instead the bullet passes completely through the block and comes out 170 meters per second. So it definitely slowed down, but it didn't slow down by a whole lot compared to its original velocity, which means it takes most of its momentum with it. It doesn't impart much of that momentum to the block in this case.